Okay, I know this is kind of boring, a little straightforward, but I want to make sure you have this available to you so you can refer back to it in case you missed something in class. Alright, so we're going to talk about solving systems of linear equations and inequalities. Alright, so thus far we've only talked about systems that have equal signs inside their equations. So what we're going to do is we're going to do a few practice or warm-ups, and we're going to graph these lines right here just so that you can remember how to do it. So remember, first you find your y-intercept as long as the equation is in slope-intercept form. Okay, we're going to find the y-intercept, which is the number that is not being multiplied by the variable. That's 5. So we're going to go on the y-axis, hence y-intercept. Alright, we're going to go on the y-axis positive 5. 1, 2, 3, 4, 5. Mark it. And then use your slope. Now be careful, the slope is negative. So it's rise 3, run 4. So usually you would go up 3 and to the right 4. But because it's negative, we need to go down 3 and then to the right 4. Or we could have gone up 3, but we would have had to go left 4 in order to get the appropriate line. Now notice, you know you did this right if the line you create is negative. If your line is positive, it means you need to redo it because that's a negative slope. Let's try this next one. This next one right here is not in slope-intercept form, so we have to get it into slope-intercept form, where y is isolated. So first things first, I don't like negative numbers, so I'm actually going to add 2y to this side of the equation. So if we add 2y to both sides of our equation, we end up with x equals 6 plus 2y. Well, I need y by itself, so we're going to subtract 6. And you get x minus 6 equals 2y. And then we're going to divide by 2. So if you divide by 2, that gets you 1 here, so that leaves you with y. And divide by 2 here. So remember, when you divide by 2, you're dividing all the pieces. So this is x divided by 2, or in other words, 1/2 x. And this is also negative 6 divided by 2, which is negative 3 equals y. Alright, so now that's in slope-intercept form, I can graph it. That's negative 3, so I'm going to go down 3 for that y-intercept. And then I have a positive slope. It's rise 1, run 2. Rise 1, run 2. And so that should do it. And we'll roughly draw that. Okay. So graphing lines, not bad. And when we get into graphing inequalities, when we graph inequalities with one variable, it's not bad. So you want all of the values of x that are greater than 4. Now remember, I'm kind of lazy, so I'm going to start with 4. I'm going to go 1 down and 1 up. And here's my number line. So all the values of x that are greater than 4. So we're going to circle 4. And we're going to fill in all the values that are bigger than 4. So 5 would be bigger than 4, so we would just fill in everything up higher than 5. Now because this doesn't say equal to, so x greater than or equal to 4, we're not going to bubble that in. We're going to leave that open to let us know that is not a solution to this sentence, or it does not satisfy that condition. Here we have x is less than or equal to negative 2. So again, here's negative 2, negative 3, negative 1, circle negative 2. Now let's see, it says x is less than negative 2 or equal to. So I am going to fill this in because it could, negative 2 could satisfy that statement. Now here, the variables, they flip. So you can either flip it and flip your sign, which I prefer to do. And right here, this piece is pointed to the x, so we need to keep that pointed to the x. It says x is less than 8, so we're going to say, alright, here's 8, 9, 7. So x is less than 8, but not equal to, so we're going to leave that open. Alright, so as we get into inequalities, or graphing inequalities like this, and solving systems of inequalities, here's a couple things you need to know. So you can see the graph of a linear equation in two variables is a line. So when I graph an equation in two variables, it's a line. The graph of a linear inequality, this inequality, so it's a number line, and it's only in one dimension. So I'm not going to fill this piece out, but this is the more important piece. On a number line, less than, or excuse me, greater than and less than, use an open dot. See the open circle, that's what they're talking about. And on the coordinate plane, so if I were to graph a line, an inequality in two variables on a coordinate plane, I would use a dotted line, and that'll make more sense in a moment. Alright, on a number line, the greater than equal to or less than equal to, use a closed dot, and on the coordinate plane, they're going to use a solid line, and that'll make more sense in a moment. Okay, so let me turn this over. Okay, so here we're going to be graphing inequalities just as a principle of practice, okay, on a graph. Now this is y is less than or equal to 4, okay. I'm going to forego these two for a moment. Y is less than or equal to 4. So I look at my y-axis and I look for the number 4. So here's my y-axis, okay, here's my x-axis, y, positive 4, 1, 2, 3, 4. So I'm going to create a line at y equals 4, like this. Now I created a solid line because that says equal to, so y is equal to 4 or less than or equal to 4. Now, because it's an inequality, just like I would shade in my number line, all the values that are less than 4, I need to do so for this inequality. Now, this whole section of my graph is less than 4 on the y-axis, so less than 4. So I would shade the whole thing in, okay, because we're using the y-axis. Alright, let's try another one. Right here, y is greater than, oh boy, we have two pieces here. Well, it looks like it's in slope-intercept form. So let's treat it as though it's in slope-intercept form for a moment. We're going to start with the y-intercept. Here's -2, go down 2. And then the slope is 2, 3. So we're going to rise 2, run 3, rise 2, run 3, rise 2. Well, we can't go further on that one, so we're actually going to go backwards a little bit. Now, before I draw my line, notice this says less than, so I can't draw a solid line, I have to draw a dotted line. So we're going to draw a dotted line here. Alright, so that's one of the differences between inequalities and linear equations. Now it says y has to be greater than this piece right here. So look at your y-axis. I want the piece that's greater than. So from here, I want everything greater than that. So we're going to shade everything that's greater than on that y-axis. Does that make sense? Alright, so those are two examples. Alright, so look here. Oh boy. Example 5, example 6. These are not in slope-intercept form. Okay? So let's say, for instance, I solve for x.